For today's webinar, this is the call for participation for the iNEMI project on the investigation of AI enhancement to AOI for PCB assembly. This is for the second phase. Majority of this presentation is a review of the phase 1 results and some sharing. We had a session early this week, and this is the second session. Roman, please go ahead. Next. So today's agenda, I will introduce the project chairs and briefly about how iNEMI develop project. Then we will have the project team members to introduce the project, including the background, objective, phase 1 achievements and summary, and then talk about the second phase. At the end, I will explain how to join, and we will have a discussion. Next. So we have 2 chairs. We have Wei Zhang from IBM. He's a senior supply chain engineer. Wei has been in the industry for over 20 years. A lot of experience with EMS industry. From the manufacturing engineering to technology qualification. In the recent years, Wei has been very active in the smart manufacturing area, including cloud computing, AI applied in different applications, including AOI and testing. So we have a co-chair from iNEMI, Philip Reyes. He's head for the China Regional Engineering Team. Philippe also has a lot of experience in the electronics manufacturing industry. Within iNEMI, he's mainly responsible for the new technology, new process development, and to integrate into the current manufacturing. Also responsible for the NPI engineering team, industrialization, assembly lines, etc. So we will, besides the project chairs, we also have 2 team members will speak during today's session. One is Roman from Mycronic, and the other is Zambri from Jebel. Okay. Next. So for iNEMI, if you are not familiar with the iNEMI project and how we develop this chart, just to give you an overview. So it's like to start or to manage a project within a company. You have those steps, right, and some stage gate process to manage. For the iNEMI project as a consortium collaborative effort, we have the same similar steps. Start from the concept through definition and planning. Then we have a launch and the execution of the project plan and the closure. I just want to point out during the planning stage, we have 2 documents developed. One is the statement of work, the other is the project statement. So those 2 documents serve as a governing document. It need to be reviewed and approved by the iNEMI technical committee. During the project concept development, definition or planning stage, we within iNEMI we call it an initiative. It's open for the industry input. Once we have entered the launch stage, in fact, this is the current stage we are now. The launch during the launch stage, we organize the call for participation webinars and put an announcement to introduce this project to the industry. Any companies they are interested, they can review and communicate with the project team, so that or even the project formation team, so that have a good understanding and also can discuss the potential contribution to the project, etc. They may have some internal review to decide the participation. So the launch stage, we need the project statement to be signed by the interested companies. So once this is completed, we will have a confirmed project team to execute the plan. During the execution and the closure, we call it a project. It's limited to the committed members who signed the project statement, so that the team has a close environment for the group to discuss, to share information, and to generate project output and decide how to manage the output. Okay, basically, the project team members are the owners for the project. Next page. So as mentioned, we have 2 governing documents for the project. For participation of any iNEMI project, it requires iNEMI membership, so that the team has a legal framework, including the terms or defined in the bylaws, IP policy, or project management policies, so that each team member, they don't need to worry about the NDAs, how to manage the project ops, etc. So for this particular project, because it's a new topic and the industry need to collaborate and develop the technology and further deploy. So we decide for this phase of the project will be a fast turnaround project. It means that we will accept non-members participation, but an MOU need to be signed, and some terms need to be defined so that they are aligned with the typical rules for the project management. I think that's what I want to talk about the iNEMI project management process and some highlighted items. Okay, I think with that, if you move to the next slide, we will enter the project instruction. I will hand over to Wei to talk about project background, etc.
Thanks, Haley. Yeah, thanks, Haley. Good morning, good evening to everyone. This is Wayne from IBM. Yeah, as Haley shared, I'm one of the chair for this project, co-chair with Philip. Right. So here I would like to share with you some of the project introduction and background, so that you can see the scope and the overall picture of the team. Next, please. Sorry. Yeah. So if you look at the title of this project, right, it's related to the AOI, and so we know the AOI has been widely used in the electronic industry for, I would say, over 2 decades already, right? So it's typically used to detect the defects. You can see some of the example images at the bottom of the slides, the chips, the ICs, and whatever typical those covered in the IP610 standards. You can see the AOI would be a typical inspection technique and tool to judge and inspect for your quality installation. But if you look at the current AOI production, right, the performance of AOI in the production, you really see some common challenges like the high false code, some escape rate related to the quality impact, and also this will be quite dependent on the complexity of your part and the product, right? So typically, the more component types, you will expect to see more AOI rejects over there. And also recently we see in the technology market, right, we call it disruptive technology, for example, the AI, right? So the AI model has been developed very quick, and recently we also heard that like ChatGPT, those called generative AI techniques, right? So all those AI tools, you have some performance index like accuracy and how we can efficiently apply that into the process, right? So this is the the technology element in our background. So I just want you to keep in mind, right? So in the next slides, we will share the details on those elements as well. Next, please. Okay, so in terms of the objective of this project, so we want to establish some common performance metrics, right? So remember, we are trying to use the AI technique into the AOI process in order to improve the capability and also to provide the recommendation to the industry, right, on any future improvement of use of by using the AI. And the bottom chart here is one example in terms of the process flow, how we apply the AI, right? So left side is typically the full step for the use of the AOI, right? So basically AOI machine inspect the card, generate pass or fail image, and for those fail image, the operator will conduct a second step inspection accordingly, right? So and the right side is the new process when we apply the AI, right? So basically the AI will be put in between the AOI and the operator, right, to help filter out some huge amount of the fail image firstly, so that the operator loading could be reduced, and also the challenges, as I mentioned, the false call, escape rate could be improved in certain extent, right? So this is the prior experience that we share in the SMT AI conference. Next slide. Okay, so for the project scope, I want you to also understand the scope that we play with this within this project team. So we want to investigate the existing and emerging AOI and AI technology status, right? So I think mostly the AOI is quite mature to the and well known by the industry, but for the AI part, it's really quite new, right? So that's why we call it emerging technology, and we want to identify what is the major AI plus AOI application, and what is the challenge to the industry for those PCBA inspections. So we focus on the PCBA commodity firstly, and we want to establish some common language and performance evaluation measures for AI and AOI. So I will assume that the audience here might be quite familiar with for those performance index for the AOI, right? For example, the false call, the escape, the first pass, things like that. But for the AI part, right, it might be new to us, right? So the terms are quite defined in what we call the data science domain, right? And in the next section, Roman will help us to introduce some of the index that we use for in the project of the project scope of our task. And of course, since we have the new stuff, new things in this project, so we the team basically develop a test vehicle, right, to put into the experiment, and we try to use the test vehicle to collect some of the data, and so that we can form a certain calculation for those performance evaluations. So the bottom chart here, you can see some typical performance index, right? That is what we collected from the team and also from the industry. So if you look at the top 3 or top 5, right? False call, escape, cycle time, CPH, metrology, MSA, that kind of things, right? So those are typical consideration when we are going to evaluate a system, right, for the AOI and AI. And also, lastly, we want to report on the AOI and AI landscape evaluation results from our experiments, and recommend a common performance evaluation framework. So this is our target. And next slide. Okay, so for the scope, so this is I would say the overall flow, right, for our project. So the top side with the red box is what we call the AI model training, right? So this is the reason we put it red is because at the very beginning of this project definition, we assume that the AI model is being available, being well trained by certain AI party, right? A third party or the AI machine vendor. So we assume that the AI model has been available after certain type of training from, like, for example, you can see the quantity, right? 50,000 or 100,000 sets of image data. So this is our early assumption. But when the project keep progressing, and we have found that more and more we actually need to touch this area by some of our AI experts in our project team. So you see some of the explanation, and also in the Q&A section, you can ask this question as well, right? For the AI related topics, so we'll be happy to answer that. And then with those AI model available, we will use the test vehicle, and then to just flow the test vehicle to the AOI, and we see the AOI will generate some good and bad images, right? So we use this AI model to how to judge or classify the results for this new image data. So this process is called the AI model inference, right? So we get the inference result. For example, it is in a category of good or in the category of defect, like open, misalignment, pins, things like that, right? So this is the overall process by applying the AI into our AOI process using the test vehicle. Okay, next. Okay, this just a clarification on the project is and is not characteristics. So this project is the purpose is to investigate the AOI and AI technology more for the PCBA level, right? So we are not meant to to develop a deep dive into the AI algorithm and model. So there are different framework for the AI development, like the Caffe, TensorFlow, you name it, right? And that kind of details we will not touch because it might be some sensitivity and special recipe from a certain player, right? We want to protect that as well. So this is the thing. And secondly, this project is for the inspection of the PCBA for classified defect types, right? So that means we are not focusing on the PCB level or the substrate IC package level, right? So this is the definition. And we will play this experiment on certain test vehicle to evaluate overall capability. And that means we are not meaning to bias some benchmarking of different suppliers, ABC or the products, right? So we want to be fair. Right, so those players are just the technical contribution to this project, and we want to respect that. And also, there will be an anonymous evaluation to have a neutral understanding of the status, limit, and opportunities, right, to adopting this AI analysis to improve AI capability. And the thing that means that we are not going to develop a standard like the IEC, IPC standard, you know that, right? So, and also, lastly, we want to establish the common language I mentioned earlier for this AOI and AI scenario. And so again, it's not a development of AI solution itself, right? So we are just going to, by doing the experiment to understand what's the common language and trying to establish that language to the industry. Okay, next. Okay, this is the phase 1 summary. So basically, you can see it have been. I think the majority of the project team here has done the update and progressing step by step in last year 2022, and we have 6 steps, right? So basically, we have the communication. You send the survey to the industry. We have received around 80 respondents. So we based on that to develop our AOI and AI workflow. And as I mentioned just now, the test vehicle, right? All those are coming from the industry survey feedbacks. And also we categorize the PCBA defects from the survey so that we can, use those defect image to train the AI model and evaluate the performance and things like that. So I think currently the test vehicle has been physically available. That is good news to the industry. And so you are more than welcome to come and join us and play together, right? So we expect that. Okay, and next slide. Okay, we have the member company, IBM, JBU, iNEMI, Nokia, Micronic, Intel, Symmetrics, Incidix, IPC, right? So yeah, we expect more company to come. Yeah, next. Okay, so I would like to touch the summary on the survey as I just mentioned. So because in the early phase of this project, we are really unclear in terms of what is the current status of what's the headache or challenge in the industry, right? Regarding to the AOI and AI, right, area. So this is, you can see the summary here. The first is the pie chart, right? So you have 72 respondents. They are coming from the top 3 is OEM, EMS, ODM, and AOI equipment, right? So they have taking up to 80% of the respondents. And you can see, if you look at the small number at the left side, right? So the AI solution provider, we only have 3 person responded from the survey. So yeah, I mean, from the scale, you can see the maturity of the AI solution is what we call really in the early phase, right? And also those respondents, if you look at the bottom left chart, they're more from the typical operation department or function, right? Test, inspection, manufacturing, product development, and business operations. So yeah, those are the expected person that we believe would be quite relevant to the AOI, and they understand challenge, and they have the desire to improve that, right? So that is the representative from the industry. And the top right side is the summary of the knowledge and experience of on AOI and AI. So the blue bar you can see is represent the experience level for the AOI, right? So we really see quite a lot of expert and intermediate level experience user on the AOI, right? But on the AI side, the AI part, which is in the orange bar, is the expert level is really in a very low count, right? And this really reflect the how to say, the experience build up learning cycle, right? For the person, right? For the resources and the team. So I think the industry still need quite, I would say, 3 to 5 years at least to build up and create this kind of AI data scientist team, right? So this is the learning from the respondents. And the last chart here is we call the word cloud, right? For the question is asking for about what is the current challenges to AOI, right? So you can see those keywords, the false, core, high challenges and programming challenges, inspection, things like that. So I think this will be something pop up in your mind as well, right? If you handle or deal with the AOI processor machines. Okay, next slide. Yeah, first chart is about the performance index for the evaluation AOI machine. But remember the performance index I just shared in the previous slide. So we also consider this is the feedback from the industry, right? So we also consider the top 3 of the charts here and top 3 or top 5, right? So we pick, like, for example, the false call rate, the escape rate into our project evaluation performance. So you see some in the next slides. And the bottom left is for the areas for consideration when you adopt the AI for AI. This is really, we don't get too much respondents from here, but some users already, they have considered the AI. So this is the consideration when they adopt the AI path. And you can see different dimensions. For example, the product factors, system for hardware and software, AI model and training cycle, and other factors as well. I don't want to go through the details of the wording here, but just give you a big picture for the consideration when playing with AI. You can see the details after Haley shared the link, right? And the top right side is the defect modes and component types, which is quite critical for us to when we jump into the test vehicle preparation and generation. So you can see 2 columns, right? The defect mode and components types. And the combination here really forms our, I would say, a top population of the components on the test vehicle, right? So I think that this is quite making sense to you, right? For example, the solder open debating, normating for chips or the QFNs, like QFPs, and lithium-leads, insufficient solder, and body marking on some ICs, right? So this is, at least to me, right, this is the common challenges, and that is well observed in my experience as well. So the last chart is for the word cloud analysis for the from implementing AI in the AOI. So yeah, so the experience covers, like, for example, escape, right? What is the accuracy of the AI model? What is the time, the hardware, and things like that. You just see the high frequent wordings. You see the some impression for the the current challenges and experience from the industry. Okay, next. Okay, so I will turn over to Zambly from JD. Zambly.
Hi, Wayne. Thank you, Wayne. Hello, everyone. Good morning, afternoon, evening, depending on where you are. My name is Zambri from Jebel. I'll be talking about the test vehicle that we use in this experiment. Due to limited timing, I will go very quick. So if you have any question, feel free to drop them in the chat box, and I would be very happy to attend to them after this presentation. So let's jump straight to the objective of the for the test vehicle creation and why it is so important. First off, we need to have a platform where we can evaluate and validate the effectiveness of the AI algorithm and machine learning models when integrated into AOI system, right? So this test vehicle will be a platform for us, right? And then secondly, we also need to have a platform where we can create defects. Obtain as many defect images as possible for training purposes and also performance evaluation. And then thirdly, not only that, we need tools to support the existing experiment execution, but we also want to make them available for future AI AOI players to enhance inspection accuracy and improve detection capabilities and optimize overall performance of the AOI system. Right. Next, Raman. Yeah, just to share the flavor of the test vehicle that we use in this experiment. Well, nothing special. It's just that it has got a lot of opportunities to produce images needed for the AI training. As you can see, it is about 4,700 CRDs with 49 type of packages ranging from 105 to QFP, SOIC connectors, and whatnot. Next slide, please. All right, this slide shows the target component placement location with their respective defect as derived by the survey from the industry survey, the feedback that we get from the survey that we conducted by iNEMI last year. They are differentiated by color coding. As an example, you see orange for open solder, yellow for insufficient, blue for lifted list, and so on and so forth. But then if you wonder why only part of the board are populated or only color coded, it's because this is just because we are only focusing on the top 20 defect as we interpret from the as derived from the survey feedback. Okay, next slide, please, Roman. These are the top 20 defects ranked by the combined score derived from the survey, as I mentioned earlier. Right, the first one is going to be solder open, the waiting and non-waiting for resistor, and then followed by capacitor. And you know, you can go through the ranking up to 20. Next, please. Right, these are the distribution of packages per board. Taking example, we have close to 900 of the O201 resistor and capacitors, you know, defect images opportunities. So for we actually built a total of 28 boards. So you can imagine we can have like more than 2,500 opportunities for O201 resistor alone and also, you know, capacitors, and we can calculate for the rest of the packages as well. Next slide, please. All right. One of the main method used in creating the defect by manipulating the stencil aperture opening. We employed aperture reduction of 30%, 50%, and 70% to simulate the insufficient solder, non-weighting, and also open solder. Other defect also used as we try to deploy contamination, lifted lead, or also wrong component. I'll go a bit detailed in the next few slides. Right. Next, please. If you look at the images for chips horizontally, the first 3 rows, these are for pads with a reduction of 30%, 50%, and 30% on single pads, only one side of the pads. And then on the fourth rows horizontally, you'll see a reduction on both sides. So these are the aperture modification that we make to create a defect, as opposed to the normal one on the last 2 rows. Next slide, please. Likewise, for leaded packages, we employed reduction on the aperture length. If you look at the second images from the top left, the top side of the QFP is 1:1, and then reduction of 30% on the right side, bottom 50%, and the left side is 70%. And then the normal one is as below. Next, please. Similarly, for other leads component like QFP, QFN, and then next slide. Okay, this slide shows the typical images of defect that we get, right? Post printing by using the stencil that we manipulate, and then component placement. In some placement we purposely offset the placement, and then you can also see on the bottom row those post reflow images, typical post reflow images. Next, please. Yeah, similarly for QFP and QFN. You can see the post-printing images and then component placement, as well as the post-reflow. Next, please. Yep. For SOIC and connectors, similar. Next, please. This slide shows method used to simulate the defect. In this case, a drop of grease was placed on the SOIC and QFN pads. So bottom photo is the images that post reflow as well. Next, please. Yeah, we replicate a wrong part scenario as well. It can either be using a totally wrong part with the same mechanical specification, or by manipulating the body marking. What we did was we engraved some lettering, and then we just to validate the wrong parts detection accuracy, and then some are different parts totally. Okay, next, please. Yeah, this is lifted lid. Yeah. Next, please. Okay. Last slide. Here are the challenges. Obviously, imbalanced representation of a component in the data set. This is obvious, as you see, as shown in the previous slide. On the distribution of packages on the test vehicle, it's difficult to have 900 of QFPs or connectors on a single board to match the quantity that we have for the auto-1 resistor. So, and on the assembly portion, when creating a defect, it is actually quite challenging to build board with specific defects. So we will not get 25,000 defect as what we want, but then somehow it is very challenging. If you look at the if you think about lifted lid, right, when we trying to manually lift the lid, it's always end up with band lid, and for contamination and oxidation, right, parts always supplied in tape and reel, and they either need to be removed from the tape and reel and do the manipulation, and then put it back to the tape and reel pocket, and then or placed it manually. So where of course it is not feasible for hundreds and hundreds of parts to be placed manually. So these are quite challenging. Yeah. So with that, I end my presentation, and again, for any question, please drop them in the chat box. I would be happy to answer them after this. And thank you, and over to you, Roman.
Thank you, Zembri. So I will be talking about the first attempts we have done here in the iNEMI project. So we've been working on the binary, what we call binary image classification, which, as we stated before, that what we want to achieve is that you have an image and we want to compute a probability that this image display a component that is defective or not defective. So I will briefly describe what we call a model, which we have often called that neural networks. That's a bit of a buzzword, but let's have a brief description of what is a model. And that's quite a simplistic mathematical object, actually. It's not, there is no magic in it. It's just a mathematical functions that have many parameters. It can be hundreds, it can be billions parameters in it, but the mathematical operations it cascades are quite simple. So this function, depending on its parameters, will behave very differently. So that's the flexibility of this model, of this function, is what is is important here. These parameters, they are changed, they are optimized during what we call the training phase. And we need data to find the best set of parameters through what we call a mathematical optimization, but this is based on data. And also one mention about what we call pre-trained model, and these are models that are publicly available, that have been trained on a very large data set, hundreds of millions sometimes, and they are used to speed up the training process. So you can use these publicly available models, fine-tune it for your need, for your specific applications. So retrain it a little bit, and then you will require less data to achieve better performance. So these are keys to understand what we are doing here and this neural networks. So before we jump to our first attempt, we want to highlight that where is the challenge in deep learning and setting this function, finding the best model to do this classification of defects. And I mean, you may imagine that this is writing the code, this is creating the neural networks, but it's clearly not that. That will take about a minute or an hour with frameworks that are, I mean, like you mentioned, way like TensorFlow, PyTorch, and so on. So this is very simple to write. To get good results, it might take a few hours, it can take a few days, which is about picking, for instance, this pre-trained model I was talking about. Then to get excellent results, you might want to reformulate your problem, also trying to change a few of the parameters that are used to supervise the training and so on. And that can be a bit challenging and require a lot more expertise. And that will take days to weeks, something like that. But then the real challenge here, that's about collecting data, and to collect relevant and labeled data that can take years, actually. So this is where the challenge here. And then what do we mean by relevant, and what is a good data set for your training? And here there are a few features we can highlight. I will not go into in detail in them, but I want to highlight the most important here for our problem. And the first one is the most important is the balance. We want to have true defects. We want to have a false defect in a balanced manner. We want the data to be properly labeled. And we have observed that about 5 to 10% actually of data is wrongly labeled when we collect them. So we have to do that again, basically. And then the last one that is important is the size of your data sets, of course. And that's a tricky one, because if you ask a data scientist if how many images he will need to achieve good performance, he will basically say that it doesn't know, and you only know that you have enough data when you already have enough data. So you can get rid of some samples and don't improve your model, then you know that you had enough data, basically. Then about the performance metric we are going to use here, and so this is what we call a confusion matrix. So basically along the rows you have what we call ground truth, which is the true label created by a human, basically. And we have along the columns, we have the deep learning model results. And here, so you have what is the most important is that we don't miss defects. And we would miss defects if for defective components, they were classified as not defective. So this is what we call false negative, and this is mandatory in the metric, is that the false negative has to equal 0, basically. So we don't create escapes, basically. And then the performance metric of the model, assuming that we have false negatives equal 0, is what we call a false positive rate, or we call that true negative rate, meaning that we want non-defective component, OK component, to be classified by the deep learning model as OK component. So this is called true negative rate. And it is also called specificity. That comes from the biological world, as opposed to sensitivity, which is the true positive rate. And so true negative rate or specificity is equal to the number of true negative over the amount of non-defective component. And we want to have this number as high as possible. We have done the first attempts for this classification model. A couple years ago, actually. It was trained on 40K images from one product. And then we got a specificity or true negative rate of 90%, which was quite good at the time. But when we applied that on the iNEMI test vehicle, we got 16%. And if you look at this image, that's quite simple. To understand. The product 0 is on the top, and the iNEMI test vehicle is on the bottom. And you can see that the aspect of these images are completely different. So that's quite an obvious statement, but if we want the model to generalize, it will require more diversity in the dataset, in the training datasets. You need to have several products if you want the model to be able to handle more diversity in the product you will inspect with that. Generalization is a term from data science, which means that the model will behave well, will perform well on unseen data during the training, on new data, basically. So we have also attempted to work on the test vehicle directly. So we picked the first test vehicle and we labeled it manually. So that's quite a tedious task. Took quite a long time to do. And so we had on this first test vehicle, we have 4,700 components. And we had that labeled by 3 people because we wanted to check if labeling was consistent. And we had about 10% of labels that were in conflict between the people. Amongst this 10%, we picked 100 and we asked the iNEMI project team to label those. And yeah, we also had conflicts in those second labeling. For instance, for this component, we had 2 people saying that it was defective and 3 people saying it was okay. So, and we discussed that when we debrief the labeling in the team, we realized that we were not asking ourselves the same question, actually. Some people were asking themselves, okay, would I repair this component? Which is exactly the question that the review operator might ask himself. But also some people ask themselves, okay, is it what I expect of my process? Do I want to be aware of that there is an issue and maybe I should take corrective actions? And so on. And the answer to these questions might be different. Hence the label you assign to an image. So we decided to go for the second one, the second question, because we want to have a more conservative approach in the way we label. So with that, we don't create escapes in any way. These are the results we got, and we focus on chips because we had enough chips to do the training on the first test vehicle. We have now 28 test vehicles, so we can scale things up definitely as soon as we have labeled those, because for now there is only one board that is labeled. So we choose to run several training for each of this package in order to see how stable, how consistent and repeatable was the training of the model. And we can see that depending on the type of package, we get a different variation, and this can definitely directly be explained by the number of samples. You can see that this is the minimum specificity we got over the 5 trainings. And we can see that it's not linked to the size of the package, but definitely to the number of samples. So we can see that we achieved almost perfect performance for 0201, given that we had about 1700 samples. And also for the for 02 that quite good results. C for 02. Yeah, so it seems to be directly linked with the size of the dataset and not to the number of samples we have in the dataset. So some of the key takeaways from the first phase of this project. Definitely, there is a very good collaboration between the member of the team. So both EMS, OEM, and AOI equipment manufacturer. We are continuously improving and getting better and better results. Then we are still in the early phase of adoption of AI for AOI. It will require an increased collaboration if we want to acquire a large volume of image data, and if we want to achieve, which is mandatory to achieve better performance for the AI models. As I said, if we have more data, we will achieve better results and more consistent and repeatable training. We can see that there is we can definitely achieve perfect results if we have a bit more than 500 chip samples by just using a generic pre-trained model. That's quite a promising result. What we have learned so far is that the size of the package does not is not correlated with the performance, not as the first of the magnitude. It's more of the number of samples. Definitely the performance of the model will depend on the quality of your data. And finally, that the real challenge is about labeling the data. That is a tedious, long task, very repetitive, and this is a true challenge we need to work on. Thank you all, and over to you, Philippe.
Okay, thank you, Roman. Hi, everyone. This is Philip Reyes from iNEMI. So now let me walk through the project timeline of phase 2 in preparation for the sign-up section. Okay, the first activity, this is the call for participation. So this is within the month of August. So in this period, if you are interested to participate, please let us know. So our project team will explain to you again the objectives, scopes, and some expected contributions from your side. Then the second activity, this is the preparation of the TV. So this is the test vehicle that will be used in the experiment. It will be fully ready and available within the month of September. Then the next activity, this is the development of the experiment plans. In this time frame from you can see from September to October, all specific goals and research questions that the experiment wanted to address will be defined in this period of time. We will be developing detailed experiment plans, line setup, and even parameters to be evaluated, and the data collection protocols. We will also consider, as Roman explained, the AI algorithms that will be used, the models and techniques to be tested and integrated into the AOI process. Then after that, we will be setting up capabilities in the experiment sites. This is 3 months, and we will start this month of October. You can see in this activity, we need to establish the necessary infrastructure, necessary resources for the AI and AOI capability at the experiment site. So we are targeting at least 3 players or 3 participating teams. Here in this chart, you can see was designated Team A, B, and C. Then after setting up the capability, then next is the data collection. And setting up the capability, we will run the experiments. Target is to do it by January 2024. The team will execute the planned experiments using the test vehicles and the integrated AI capability in the AOI. So in this experiment, a protocol will be followed, collecting all the relevant data and documenting all observations and deviations that we will be encountering during experiment. Then the next activity, this is the data collection and analysis. So this will start by March and April. We will be collecting all data generated during experiments and conduct a comprehensive analysis, statistical analysis, visual interpretation, and we will carefully evaluate the performance of the AI enhanced AOI system, comparing with the baseline AOI system. Then lastly, we will summarize and provide recommendations. No, the target is by March to April of 2025, we'll be summarizing all the key findings and outcomes of the experiment and data analysis. So there will be a comprehensive report. We will be prepared, highlighting the effectiveness of this experiment, the AI enhancement in AOI. So this includes improvement accuracy, efficiency, and defect detection capabilities. And by this, we will also be providing recommendations for further enhancements and implementation strategies and potential areas for future research or development for this project. Okay, so that's all. I hope I gave you a clear overview of the phase 2 activities. Then let me go through the benefits in participating in this project. Okay. So the first benefit is the ability is to understand the current capability of AOI and AI solutions, which can help in defining future AI solution scenarios for improving your AOI process. So this benefit enables the manufacturers to assess their AOI process, identify improvement opportunities, and even defining the future AI solution scenarios. So this knowledge helps in enhancing inspection accuracy, reducing false positives, and increasing efficiency, and also will drive continuous improvement in the manufacturing process. Then the second benefit, this is the collaboration or working together between AI and AOI, as this is one of the key takeaways that Roman explained. The collaboration between AOI equipment vendors, EMS providers, and OEM users offers a benefit in terms of achieving a better understanding of what to evaluate and how to apply AI technology for existing AOI solution. So in this collaboration facilitates knowledge exchange, evaluation of real world application of this technology, a user feedback gathering, and solution customizations and continuous improvement. Ultimately, it leads to more effective, tailored, and optimized AOI solutions that meet the specific needs of the manufacturer. Then third, this is the integration of AI and AOI offers a benefit in terms of increasing inspection efficiency and accuracy while we will be reducing the need of manual inspection verification and mitigating the risk of defects escaping detection. So, here in this integration, it aims to increase inspection efficiency and accuracy while reducing the reliance on manual inspection verification and mitigating the risk of defect escape. Then, by defining a common language and performance evaluation metrics can accelerate technology development and adoption. So this is by leveraging AI and AOI systems, manufacturer can achieve higher efficiency. It will result to improve accuracy and enhance quality in their production processes. So these are just the major benefits that we assessed and we see and we saw. So okay, then looking forward for your participation. So let me endorse back to you to Haley for the sign up section. Thank you.
Phil. Yeah, I will talk about how to join the project. As mentioned earlier, we have two documents, the SOW and the project statement. The SOW is really the plan. You can see it basically it includes the schedule and the resource and some explanation of the project scope, etc., as introduced in this presentation. The project statement is commitment to the terms that are defined either in the iNEMI bylaws or the project management policies, and some resource contribution that will be needed for this project. So you can download those two documents from the iNEMI webpage. There is a link. Once you get the presentation, you can have that, or you can just visit iNEMI webpage. For the participation of this project, as mentioned, we will open for the non-members. For the existing iNEMI members, they can just sign the project statement. It's quite straightforward. For non-members, I believe we will have some communication first, and because if anyone want to participate in the experiment, the current status, the development status or the deployment status could be different from different players. So the specific experiment plan and the scope and how we collaborate that need to be discussed. So we will sign a MOU for non-members together with the project statement, so that we share the same terms as defined in the project management rules. Okay. For the non-member, it's a fast turn project. It's only one project of iNEMI can accept that. It means that cannot at the same time participate multiple iNEMI project. Okay. I'm the facilitator for this project. If you have any questions, let me know. And now we will open up for the questions and some discussion. If your time allow, you can stay a few minutes longer. Okay. So, is there any questions from the attendees? You can unmute yourself and just speak out. As you can see from today's webinar, the team members are quite active, and they are getting engaged and a good collaboration basis in the past 1 or 2 years. So we do look forward to have more participants so that we can together join the journey to explore the technology and how we can do it better. Are there any questions?
Yeah, any question, particularly for the AI part, right? So we have the expert ready.
Hey, DCL, just to kickstart the question. I mean, okay, yes, to the team, I mean, what do you have in mind? I mean, the success criteria to conclude that AI actually is adding value to the current AOI process?
Wei, do you want to comment?
Yeah, I also want to know the answer from Roman, but my personal view is that we need to see the actual data, right? CR, right? For example, if we apply this AI solution in a certain trial one in the production, so probably we'll arrange 1 or 2 MO, right? And then we will collect data and see. So there are some as we share in the performance index, the false call rate, escape rate, and also the overall, I would say, operator loading and efficiency improvement. Right, we can collect those data and see what is the outcome benefit from there. And by collecting this data, you can actually calculate the ROI, right? ROI, so you can say whether this meet your financial objects to invest into a certain AI solution for this domain. Yeah, that's my thought. Yeah, Roman, do you have any more?
Yeah, I cannot.
Oh, Philip.
Yeah. Go ahead.
No,
Okay.
I was about to say that there is already, for me, one great achievement, which is building the test vehicle, thanks to Jebel. I think that's a very great tool for us to assess the performance. So for my colleague, it's already a step forward. I'm really glad to participate to this project. First, because of this first step, that for me is key. And then, as you can see already on chips, we can really achieve very, very good results, actually more close to perfect. Reducing the amount of false call on this product by almost 100%. So that's already a very great achievement, I think. And we need to, once we have covered all the labeling of all test vehicle, then we can move to extend this to all components on the board, and that will be a great achievement.
Okay, sounds good. Thank you. I mean, because in the earlier slide, we say that we are looking at the AI to reduce the workload of the operators. So I was wondering whether, we are setting as a KPI, for example, if the AI is able to reduce by 50% of the false call images, will that be defined as a success or not?
Yeah, I think here the idea is to evaluate how much we can get rid of false calls.
Thank you.
Yeah, we have one question in the chat channel, right? From the first phase, we saw the time effort to improve the specificity is rather huge compared to adjust the AOI using rule-based algorithm. Is this given scenario, what is the AI's value add that we are targeting by adding to existing rule-based algorithm? So Roman, I guess this question to you.
Sorry, I had a glitch in the sound. I have to look at the chat.
Yeah, no problem. You can unshare.
Yes.
Now.
Okay. Let's do that. Oh, yes, that's right. And the idea is to have to do that only once for this product, and then you can apply that to others. That's the whole idea. It's once you have data ready, then you have only to do that once. Let's say that you have I don't know 10 products that you have labeled only one board. So that will take a few days or maybe a couple of weeks to create your data set. And then this component will have very low level of false code anymore for all the products you are going to produce in the future. So that's an investment you do. And what you need is to compute the return on investment, the major investment being the labeling of your data. And I agree, if you do that only for one board, then it's a huge investment compared to the benefits. I fully agree.
Okay, there is another question in the chat. Are you open to AI solution provider? I think generally yes. or do we need to find AOI machine supplier? Yeah, in fact, we do have AOI machine supplier within the team. Certainly, we expect more, right?
Yeah. So as you can see, the protocol, the mechanism, the team playing here, right? So we basically generate the data from the test vehicle. So with those data, you can either input into your AI solution or the AI part of your AOI machine, right? So depends on the architecture that you are using. So I hope this answered the question. Yeah. So yes, we are open to the AI solution provider. Yeah.
Haley, also regarding the question about the AI value add, yeah, I just want to add up now. Yeah, basically, if we integrated AI to the current AOI systems, no, so we can achieve a higher efficiency. We can achieve higher efficiency. We can improve the accuracy and even enhance the quality control in our production processes. So mainly, this will drive continuous improvement in the manufacturing process. So that's those are the three value adds. It's inspection accuracy, quality by reducing false positive or false negative, and increasing efficiency. So that's the value add.
Yeah. I also want to echo that, Philip, for the first question, that why we consider AI, even though the AI needs some investment, right, for the labeling, for that kind of all of those efforts. But considering the AI is what we call the disruptive technology, meaning that the current challenge for the traditional AOI, for example, if we want to further improve the post-call performance from the process, right? So I think you get a certain limit extreme, right? So that you cannot break through that boundary. But by using the AI, it will help you to break through that boundary and have the further improvement on that. I think that is becoming one of the competition in the market, right, from a company perspective. So I think that's the true value to consider here.
Yeah, that's true. That's true. And this will also it will greatly reduce the reliance on the manual inspection verification, because we know if we encountered false reject, right? So we use the operator to verify it, and that process we encountered lots of quality issues, inefficiencies in the line, output in the line. So yeah, it's one of the good value add of AI being integrated in the AI.
Yeah, hi.
Okay.
I have a question.
Thank you.
Sorry. Hello?
Sure, go ahead.
Yeah, hello. Yeah, I have one question that is, I saw we have the, let's say, the leader defects, right, in our scope from the presentation. And I'm wondering, typically for leader, we are using 3D inspection. It will more easily to capture these kind of failures in compared with the typical 2D AOI algorithm. My question will be, do we also, let's say, including the 3D dataset in our AI strategy or in our AI neural network or not? Especially for those 3D data sets, something like that.
Yes, and thank you for the question. That's a very good question, actually. I mean, the AOI and most of the AOIs you will find on the market have different type of lighting and the 3D capability. So definitely it's possible to merge all the information from all this type of modality of imaging. In either in an early phase in the network as an input, you can have multiple inputs in your model, and then return the same. So yeah, it's definitely possible to combine. Philip, you are unmuted. Thank you. So you can merge all this data to really harvest the full potential of your data. I don't think there are any network model, pre-trained model for 3D. but you can actually use the ones for 2D to do quite a good job on that as well.
Yeah, I see. Because we see that sometimes if we are using the 3D AOI, we will have a little bit different, let's say, algorithms that we are using to process those 3D data sets and set the, let's say, parameters to identify those least defects. Because we believe with this one more dimension data compared with 2D, we will more easily to identify those failures, right? But if we are using 2D, sometimes it will have some escapes. That's why I would like to know that, yeah, because maybe different machine supplier based on their 3D technology, the data set will be totally different, right? Therefore, but for 2D, I think it's typical, let's say, image data sets, right? The neural network can easily handle those, let's say, pictures or let's say, image data sets. But for the 3D, I just have some this kind of cultures, because different suppliers, different types of the data set, how we can handle those situations. So in this case, we focus maybe on 2D. Yeah, I think I'm also fine about that.
Yeah, I mean, in the first attempt, we did focus on 2D, but we can definitely extend the experiment to 3D. And actually, the model, when I said that it will have 3 inputs, the model will, during the training, will use more the image that is more relevant for the probability. If it ends up being the 3D, then fine. It will somehow, reduce the influence of the other inputs on the final results during the training by itself.
Okay.
Yeah, that means
Thank you for
we
the
use
question.
the 3D image data to train the AI model. So that's a interesting topic. Hopefully, we can have this scope in the future someday. Yeah.
Okay.
Thank you. Yeah, Silly.
Yeah. Thank you. Thank you.
Okay, any other questions? Okay, I think, yeah, very good comment or suggestions. If you have any further questions or once you review the documents, you have anything, just contact us. I think myself and also the team members are willing to have a further discussion with you, and welcome more participants. Yeah, hopefully always if we have more resource, everybody put a little, then we have more, and bring in different capability and thoughts and expertise, so we can do much bigger scope. Okay, and with that, thank you again for your participation, and also thank all the speakers for today's presentation. We will share the presentation material and the recording next week. Thank you.
Yeah, thank you.
Thank you, everyone.
Have a good day. Have a good night.
Yeah.
Thank you.
Bye-bye.
Bye-bye.
Thank you,
Have a
everyone.
good day.